I'm Craciunescu from Wealth Wizards. I'm one of the platform engineers. This talk is actually based on the talk that my colleagues Dave Shepard and Pierre Menuet gave at KubeConf U in Barcelona this year. And I'm here because they couldn't make it and they sent me instead. I'm a bit of a mountain bike geek, so you'll see a few more pictures like this, fortunately or unfortunately. Wealth Wizards. It's a fintech based in Leamington Spa. We have two applications. One is called Maiva. You can go and register with your email address, give some details. It gives you a financial MOT. Another one is called Churo. It's aimed at financial advisors to help them giving financial advice. Both applications are FCA regulated, and the company is FCA regulated, as in Financial Conduct Authority, is a governing body doing legislation in financial world. So pretty much that everything we do has to comply with loads of regulations. We get loads of auditors from all over the places. Now, our applications, they are microservices based, similar to these bikes in a bike parking lot somewhere in Denmark, I think. There's loads of them. And when we deploy microservices into our production environment, to find a good balance between going fast and be flexible and still comply with change control, for example, we deploy off the master branch. So basically our change control process is, there's a feature branch, development takes place, pull request, classic thing, pull request against master, gets reviewed, gets approved, deployed to master, and that's it. So the pull request in itself, it's our change control mechanism. But since everything goes off master, you can see how that can go wrong sometimes. Wrong as in delayed, similar to these guys waiting to go down the mountain. If everything goes from master branch and you have 3, 4, 5, or 10 changes waiting to go into production, they might all get queued up, one behind each other. Or if there's changes coming in, new information, say, okay, this change has to stop. It might delay the others. And you're thinking, okay, how can we solve this problem? It's slowing down our deployment pipeline, it's slowing down developers, we want to go faster. And then we said, okay, what if we make the deployment pipeline large enough so everyone can go at its own speed, have its own path from start to finish, can go as fast or as slow as it has to be, as it needs to be. And we looked at various ways of doing that. Service meshes on one side, feature flags, beta users. Feature flags. If there's loads of changes, let's say you have 20, 30, or 50 changes that they all have to go into your development environment, it becomes a bit tricky to maintain all those changes behind feature flags. There's a lot of overhead. We used it for a while, then we backed out. We found out we spent more time doing pull requests for this change flag, or do this, do that. If A, then B, then C, then E. Oh, okay, I don't want to manage all of that. We still use feature flags for some of the production launches, but it's not the main way we release into production. Similar with beta users and with microservice environments, we've been asked, why not spin up a new environment for every change that I have? And said, okay, that's going to be insanely costly, difficult to manage, not going to do it. It was an easy choice. And then we said, why not spin up only the changes? I have this change in my microservice, say, deploy my change alongside the other ones, and then talk to that change. And here is where ISTIO comes into scene. ISTIO in itself, for those which don't know it, it's a service mesh. The way it basically works, it is injecting a sidecar in every pod. That sidecar runs Envoy proxy, and it injects some IP tables rules on the host. And all traffic going in and out of that pod is being redirected and basically goes through Envoy proxy. And there's a bunch of rules in there which tells Envoy how to route traffic, or if it needs to do any traffic controls, if it needs to do TLS, for example. ISTIO has loads of components. It has a control plane. Citadel is a pod which manages basically PKI for ISTIO if one chooses to do mutual TLS between pods. It has Mixer. Mixer is responsible with pulling data from Kubernetes API and keeping ISTIO up to date with whatever is happening on Kubernetes, how many pods, how many services. Pilot is the component which is responsible mainly with creating Envoy configuration and pushing it onto Envoy proxies. So most of the work happens on Pilot, and it's quite CPU intensive. all rules that are pushed from pilot to envoy are usable for traffic management. It can route traffic based on headers, in this example, based on user agent. You can do clever stuff with canary deployments. You can tell it even route 10% of the traffic to this set of pods. How did we deploy the ISTIO on our cluster? Basically, is this thing, ISTIO ingress gateway, which is the entry in the service mesh, and the pods themselves, they have envoy injected. So traffic goes into load balancer, Nginx ingress controller, goes into ISTIO ingress gateway, that's the entry point into the mesh itself, and then it's all managed by ISTIO. A bit of a demo time, hopefully it doesn't blow out in my face. And okay, so this is a dummy example just to show how ISTIO, how we use it for traffic management. Let's say I'm a developer and I've been told, hey, I don't like this case list over here, I want to change it to something else. I go in my repository, I make a change, I add my new text. In this case, I've already done the change, it's already been pushed, the build time takes a while, a few minutes, and then I can start using it. And I have an extension in my browser. I can go and say, okay, send me a header called xvariant_id, which is matching the branch name. I take that one, I go and refresh my UI, and there you go. I can go and see my new changes, and I can use them going forward. If I choose a different number here for a branch which doesn't exist, or if I don't have the header set, it will be routed to the default master deployment, as we call it. So basically the main line. Going back to ISTIO, the way we do that, we have a deployment tool for Kubernetes that we wrote ourselves even before Helm existed. So for every deployment, we label it with a version matching the branch name. Then we also have a destination rule in ISTIO. So that's an ISTIO configuration rule. And the destination rule goes and finds all pods behind this service which have a label ops1234 and makes up a list with them. And then we have a virtual service. Basically, we have two types of virtual services. We have one for the entry in the service mesh and one for traffic within the service mesh itself. And the reason for that is because we want to route traffic based on host name as well. And host name, this is a public FQDN. This FQDN is not available inside the cluster. So you just have to basically do a bit of duplication. And in this rule, the envoy proxy is looking at headers. If it has the header ops1234, actually it's this example, it will route to a subset of pods that have label attached ops1234. So the traffic goes from envoy to envoy directly. It doesn't go through Kubernetes service. It's pod-to-pod communication. This is the virtual service for traffic inside the mesh. It's pretty much similar to the previous one, except it doesn't have this rule, which is matching on the host name. And that's basically it. The only configuration we had to do on ISTIO itself. Now, how is this managed? We have loads of pods. They all have to be deployed the same. What cookie cutter have we used? We wrote a few automation tools ourselves. One of them is called AutoKube, which listens on the ingress on Kubernetes API for deployments. It has a bit of logic, some templates, and for every pod or namespace, which has an annotation which says ISTIO enabled, it will go and update virtual rules and destination rules. We do loads of, developers create loads of branches. They live there for maybe 2 weeks, but we don't want the deployments to stay on the Kubernetes cluster for 2 weeks. So that way we have what we call Kube Housekeeper. It will go and delete all deployments which are older than a timer, 2 days or 3 days, depending on the project. We have discussions with developers and basically we agree on how much time they need them running. And we've also wrote a thing called Hpropagate. Hpropagate is basically a Node.js module. And its responsibility is to pass headers to downstream systems. It's very easy to use. The only thing we have to do is require Hpropagate, and that's it. Now the question is why we've done that. Let's say we have service A calling to service B, calling to service C, to doing its workflow. It's nice and easy routing traffic to the first service A, based on the headers. But when the outbound traffic goes to service B, no information is there telling me, okay, where should I go? So Hpropagate grabs the input headers and passes them to output. by default is doing X variant ID, the header I showed it in the previous demo, is doing also correlation ID, so you can have a full trace to the system for service A calling B and C and so on. So it's quite easy, didn't took much time to develop it. It's free on GitHub. The other tools are on GitHub as well, so you can go and use them, have a look. Because we use ISTIO, we also get Jaeger for request tracing. It's pretty good, to be honest. We get fancy maps. We recently had a request from one of the developers asking, hey, I have this request. Is it going to service X, Y, and Z? I think it does. Let me look on this software called Kiali that comes by default with ISTIO. And I've got this service and say, yeah, it's all great. 9 months later, so we're 9 months in since using ISTIO. How is it working for us? Well, it's great. We're pretty happy. We couldn't do without it these days. We'd slowed down so much the deployment and development pipeline. Devs and QA as well would hate us. Probably the business would hate us if we take ISTIO out. It made releases easier. It also improved collaboration because it exposed developers in QA to a bit of infrastructure, and they have to go every now and then, okay, I need to use this header, is my pod there? So we had more collaboration among ourselves. Was it easy, right? I'd like to say yes. Ish. ISTIO has a steep learning curve. Kubernetes in itself is complex. ISTIO is just as complex. There's loads of moving parts, loads of new things that one has to learn. It had some stability issues for anyone using ISTIO. Yeah, it made that guy go over the handlebars. Back in the days, I think version 0.5, definitely 0.5, that's when we started using it. 0.6 up to 1.0 snapshot 3. We were getting 503 errors. What was happening when a pod was being terminated or was removed from the cluster, ISTIO wasn't catching up with that event quick enough and was still routing traffic to that pod. And one way to work around it or to improve it was to add retries at the TCP layer, and that removed most of 503s, but then pilots themselves in default configuration, they were not having enough resources, enough CPU to cope with the workload, so you have to give it more resources. Again, by default, they are deployed using horizontal pod autoscaler. It goes from 2 to 6, if I remember correctly. It goes up and down with load. We found it's better to have a fixed number of pilots, give them enough CPU to cope with the load, and we are also running it on dedicated nodes on C-type instances, compute optimized. We were at a point where we said, okay, it's quite difficult for us to maintain this thing. We all have Kubernetes, we have ISTIO, we have loads of issues. Should we still keep it? And thinking about the value it gives us, we said, okay, let's push on, find ways to make it better. And luckily, in time, ISTIO developers improved CPU usage, and Pilot itself became more performant, and they solved loads of issues. We're now on version 1.2, which we upgraded in January. We didn't have to do any changes since then. It works at which we are quite happy with, to be honest. As a summary, using ISTIO solved our deployment bottleneck. We're able to deploy every feature individually. We also have plans to use similar traffic management approaches to or release some stuff in production. Something around the UI. It's a bit difficult to explain now. We push the complexity into the platform, so the applications themselves, they don't care what's happening, they are blind. ISTIO is complex, but it's also feature rich. There's more it can do, so there's more for us to explore. As I said, Hpropagate is on GitHub along with the other projects. We also have a medium engineering. By all means, go and have a look, add comments. This is the end of my talk. Thanks for listening. If you have any questions.